question for you. When you ask ChatGPT to write you a poem or when your phone recognizes your face to unlock, what do you think is actually happening behind the scenes? Now, you might think it's all computer wizardry, and you wouldn't entirely be wrong, but here's the thing that might surprise you. It's actually mathematics. Pure, beautiful, sometimes centuries-old mathematics that's powering these seemingly magical technologies. I'm here to take you on a journey into the mathematical heart of artificial intelligence. And I promise you by the end of this, you'll never look at your smartphone the same way again. I'm Autumn FNAF, and we are going on to a little journey on today's episode of Breaking Math with algorithms. Let's start with algorithms. And no, I don't mean the mysterious forces that decide what you see on social media, though we'll get to those later. An algorithm is simply a set of instructions, like a recipe. But here's where it gets more interesting. The algorithms powering AI aren't just any old recipes. They're mathematical recipes that can learn. Take machine learning, for instance. At its core, it's about finding patterns in data using something called optimization. Basically, mathematical trial and error, but done millions of times faster than any brain could manage. The algorithm looks at data, makes a guess about the pattern, and then checks how wrong it was and then adjusts. Rinse and repeat until it gets rather good at making predictions. That's happening in layers. It's kind of like an onion of mathematical functions. Each layer learns something slightly different, building up from simple patterns to increasingly complex ones. It's like how you might learn to recognize faces. First, you notice edges, then shapes, then features, and finally, yes, that's definitely your mom. And natural language processing? Well, that's where we teach computers to understand human language by turning words into numbers and finding mathematical relationships between them, which, when you think about it, it's absolutely bonkers. And yet, here we are having conversations with machines. Now, let's dig into the mathematical toolkit that makes this all possible. And don't worry, I'm not going to throw equations at you like some sort of academic food fight. First up, we have linear algebra. This is the mathematics of lists and tables, what we call vectors and matrices. So each piece of data in an AI system gets turned into numbers and organized into these mathematical structures. Your photograph, it's really just a matrix of pixel values. Your voice, a vector of sound frequencies. It's linear algebra that lets us manipulate all this data efficiently. Then there's calculus. Yes, indeed. That calculus you might have struggled with in school. In AI, calculus is what helps us find the best solution to a problem. Imagine you're trying to find the lowest point in a mountainous landscape when blindfolded. Essentially, calculus gives us a way which the direction is downhill and then take the steps forward to the bottom. In AI terms, we're usually trying to minimize errors, and calculus shows us the way. And here's where probability and statistics come in. Because the real world is messy and uncertain, AI systems don't just need to make predictions. They need to understand how confidently they should be in those predictions. So when your weather app says that there's a 30% chance of rain, that's probability theory at work, helping AI express its uncertainty mathematically. These three mathematical pillars work together like a well-orchestrated symphony, each playing their part in creating intelligence from data. So where is all this mathematical wizardry actually being used? Well, practically everywhere, and often in ways that might surprise you. In healthcare, AI is reading medical scans with mathematical precision that sometimes surpasses human doctors. It's not that the AI is smarter, it's that it can process vast amounts of visualized data and spot patterns that human eyes might miss. The mathematics of image recognition combined with statistical analysis of thousands of previous cases, it creates a powerful diagnostic tool. In finance, algorithms are making split-second trading decisions, assessing credit risks, and detecting fraud. Every time you tap your card to pay for something, there's likely an AI system running calculations in the background, determining whether this purchase fits your spending patterns or if something fishy might be going on. And transportation? Well, self-driving cars are essentially mobile mathematics laboratories. They're constantly solving differential equations to predict where the other vehicles will be, using linear algebra to process sensor data, and employing probability theory to make decisions under uncertainty. Every journey is a real-time mathematical problem-solving exercise. But and this is crucial. With great mathematical power comes great responsibility. These systems can perpetuate biases present in their training data, make decisions we don't fully understand, and impact people's lives in profound ways. Mathematics might be neutral, but the data we feed it and the ways we choose to use it certainly aren't. Here's something rather exciting. Now, we're witnessing a renaissance for mathematics. Suddenly, skills that were once confined to academic ivory towers are in huge demand in Silicon Valley and beyond. The collaboration between mathematicians and computer science is creating breakthroughs we couldn't have imagined just a decade ago. Mathematicians bring the theoretical rigor and deep understanding of fundamental principles, while computer scientists, on the other hand, provide the practical implementation skills. Together, they're pushing the boundaries of what's possible, and this isn't just about creating the next cool app. Mathematical literacy is becoming as important as traditional literacy in preparing for our AI-driven future. Understanding the basics of how these systems work, even at a conceptual level, helps us become better users, critics, and citizens in a world increasingly shaped by algorithms. Here's the really empowering bit. Understanding the mathematical foundations of AI doesn't just satisfy curiosity, it gives you agency. When you understand that AI systems are making mathematical decisions based on data, you can better evaluate their outputs, understand their limitations, and even contribute to their improvement. Here's what's the really empowering bit. Understanding the mathematical foundations of AI doesn't just satisfy curiosity, it gives you agency. When you understand that AI systems are making mathematical decisions based on data, you can better evaluate their outputs, understand their limitations, and even contribute to their improvement. The potential applications are staggering. Climate change? AI models are helping us understand complex climate systems and optimize renewable energy distributions. Poverty? Machine learning is improving crop yields and helping deliver aid more effectively. Now, medical breakthroughs, AI's accelerating drug discovery, and personalizing treatments. But here's the thing, and I can't stress this enough. The mathematics itself is just a tool. The real power lies in how we choose to wield it. We need mathematicians, yes, but we also need ethicists, policymakers, and informed citizens working together to ensure AI develops in ways that we benefit everyone. So the next time you interact with AI, whether it's asking for directions, getting a movie recommendation, or even listening to a podcast just like this one, remember that you're witnessing mathematics in action. Beautiful, powerful, centuries-old mathematical concepts working together to create something that looks remarkably like intelligence. The future isn't being shaped by technology, it's being shaped by mathematics. And now that you know that, you're part of the conversation, because understanding the mathematical heart of AI isn't just about satisfying curiosity. It's about being an informed participant in the world we're creating together. Until next time, I'm Autumn Fnaf on Breaking Math Podcast, and always stay curious and...
If you're a lineman in charge of keeping the lights on, Grainger understands that you go to great lengths, and sometimes heights, to ensure the power is always flowing. Which is why you can count on Grainger for professional-grade products and next-day delivery, so you have everything you need to get the job done. Call 1-800-GRAINGER, click Grainger.com, or just stop by. Grainger, for the ones who get it done.
Stay informed.